Hi Dr. Zhang, my name is Kelvin Juki. I'm going to make my project presentation. Mainly I was looking at whether gender, education level and distance learning affect numeracy score. In this project, I use data from the Program for the International Assessment of Adult Competencies, which is a program that assesses and analyzes adult skills. The data collection was done between 2011 and 2018, and it was done in 3 rounds. The first round was in 2011 that involved 24 countries. The second round was in 2014 that involved 9 countries, and the third round was in 2017 that involved 6 countries. Among the key variables reported in the data are numeracy, literacy, and problem-solving scores, age, gender, education level, distance learning, race, income level, and employment status. In my project, I'm looking at 2 statistical questions, and the first one is, does numeracy score get affected by gender, education level, and distance learning? And the second one is, which combination of gender, education level, and distance learning yield higher numeracy score? Variables of my interest are going to be, response variable was the numeracy score, the predictors were gender, education level, and distance learning. Each of these predictors earned 2 levels. Gender earned male and female, education level earned at least college formal education and lower than college level education. And the distance learning earned 2 levels as well, one being the participant participated in distance learning for the last 12 months, and the other one was the participant did not participate in distance learning for the last 12 months. The response variable and the predictors are going to help me answer my 2 statistical questions. To start with, I conducted exploratory data analysis to gain insight into the data. On the left, we can see a comparative bar graph. In this one, on the x-axis there is average numeracy score, and on the y-axis we have gender, and the graph is visited by college education and participation in distance learning. Looking at it clearly, we can see male who earned at least college education and participated in distance learning performed better. At the same time, male who earned at least college education and did not participate in distance learning also performed better. The worst combination was female who did not participate in distance learning and they earned lower than college education. So the comparative background shows clearly that there is differences in these different combinations of our 3 predictors. Looking on the right, we have a combined violins and box plot of numeracy score by gender, education level, and distance learning. The medians clearly show that there is differences in median numeracy score for different combinations of gender, education level, and participation in distance learning. And looking again clearly, we can see in each of these combinations, the numeracy score are normally distributed. In our next plot, we are going to look at that, and we can see the histogram with kernel density curve here shows that numeracy score are normally distributed. This tells you the choice of the model. When modeling, I can use normal general linear regression model with identity link as the data or as the plotter suggesting that numeracy score follows normal distribution. So the next part is analysis methods and summary of my findings. To start with, as we have seen from the exploratory data analysis, normal generalized linear regression model would be appropriate for this data. So I have a model that has my three predictors and the interactions of the same. And as I mentioned earlier, gender, education level, and distance learning have each two levels. So I started by doing a model selection, and this was done in R, and I used a forward selection procedure with Bayesian information criterion. The best model that was identified or that was selected was a model with the three main factors and an interaction term between education level and distance learning. As you can see down here, we have our model. Next, I went ahead to do the model diagnostics to make sure that my model is valid, and when I'm interpreting my results, they will be valid as well. So looking at my plot, the top left one indicates some homogeneity of variance for the residuals, and that is exactly what you need. The top right plots indicate that the residuals are normally distributed, again, which is as per expectation. And down here, the bottom left, we can see another plot. This one simply emphasizes on what is on the top left. And the last one shows that there were no values that were so large such that we aim to eliminate them. So basically, the four assumptions of generalized linear models are met, and this gave me a go ahead to go ahead and interpret my results. So I went ahead to test the four different hypotheses, and the first one was finding out whether gender had a significant effect on numeracy score when education, distance learning, and the interaction term were already in the model. So basically what I'm doing in this hypothesis testing, I'm testing the effect of the partial coefficients. That is, if one of the factors or if other factors are in the model, adding another factor, how is it going to affect the expected numeracy score? So the second hypothesis is education level had no significant effect on numeracy score when gender, distance learning, and the interaction term were already in the model. And the third hypothesis was distance learning had no significant effect on numeracy score when gender, education level, and the interaction term were already in the model. And the fourth one is the interaction term between education and distance learning and no significant effect on numeracy score when gender and education level were already in the model. So looking at the results, I used world test to conduct or to test these hypotheses. And we can see the first parameter, the p-value is 0.0, which is extremely small, an indication that we are going to reject our null hypothesis and conclude that truly when other factors were in the model, adding gender in the model significantly affected the numeracy score. Similarly, for our beta 2 and beta 4, you can see they are contributing to the model. Our beta 3, which is the distance learning, the p-value seems to be a bit high, so we are going to fail to reject the null hypothesis in this case. But because in beta 4 we have an interaction term which is between education level and distance learning, when modeling, that's why we still have distance learning in our model, because it is appearing in our interaction, which is significant. So next, I went ahead to fit individual models. As I mentioned, we have two levels of gender, two levels of education level, and two levels of distance learning. So there are 8 different combinations we can get from these 3 factors, each with 2 levels. And I went ahead to find out if I take gender being male and this person has at least college education and participated in distance learning, what will be the expected numeracy score? And as we can see from these results, this person is going to be the best in a numeracy score. And coming second is a male who has at least college education and did not attend distance learning. And the worst will be a female who has less than college education and did not attend a distance learning. So basically we can see what will be the expected numeracy score for different combinations of gender education and distance learning levels. This would help the United States, which was our main interest in this data, to put more effort maybe on education and distance learning to make sure that people in this nation have higher expected numeracy score. And basically that's all I earned from my project. Thank you.